Hi folks, we're going to take a look at page 40, number 6a. So here's an example of determining the equation of a polynomial function based on its graph. Okay, so first of all, I do notice that it's going to be an odd degree graph. Okay, so let's start by looking for the x-intercept. So we see that we have two x-intercepts. We have one at -2 and we have one at 3. So right off the bat, I know that if we write it down here, we've got one of our factors is going to have to be x plus 2 in order for us to have our x-intercept of -2. And I notice here that it seems to be that it's got a cubic look to it. So I'm going to assume here that that means that it's a 0 of order 3. I mean, could there be, a similar function that might have a 0 over 5 here? But again, we want to go with the simplest possible scenario, and it doesn't look particularly flat there. So it makes more sense that this is order 3. And if I look here at x equals 3, meaning we're going to have a factor of x minus 3, okay, I see that it just bounces off the x-axis, so that's going to be a quadratic or an order 2, 0. Okay, what we don't know is what stretch factor there might be. Okay, because there's infinitely many functions. It could be a function that does this and doesn't go up as high, and then touches the axis and goes up. Okay, there's infinitely many I could draw that have these same two characteristics. Okay, so that's why we need this stretch factor. But we have another piece of information. We know that this function crosses through this point here. And there doesn't seem to be any other nice point that I can see right off the bat. Okay, so I will use this point here. So this is 40, so that's 60, so it looks like that's 70. Okay, so that means we have the point 0, 70, which is on the graph. And so this is what we're going to use to determine our missing component here. Now, by the way, if you look at this equation, you see 3 plus 2. This has a degree of 5, which does fit with our graph. We know that it has to be an odd degree graph. Okay, so in terms of actually determining the a value, nice and easy, we're just going to stick this into our equation. So when y is equal to 70, x is equal to 0, so 0 plus 2 cubed, and 0 minus 3 squared, so 70, and here we've got a, so this is going to be 8, and this is -3 squared is going to be 9, so we have 70 equals 72a, and so a is equal to 70 over 72, which of course I would expect you to simplify that, so divide them both by 2, and we have 35 over 36. Okay, so our final answer is going to be y equals our a value, which is 35 over 36, which, by the way, if we look at our graph again, makes sense that our leading coefficient should be positive, because I'm going from -infinity to +infinity. Okay, if I'd gotten a negative, I must have made a mistake. Okay, so 35 over 36, x plus 2 cubed, x minus 3 squared. So step 1 is determine the zeros and their orders based on the shape near the x-intercept. Determine another point on the graph. In this case here, it happened to be the y-intercept. Input this point into the function. Solve for the stretch factor. And make sure you're giving me your final answer at the end. Okay, that's it for this one.